Hi, this is Djordje, and in this video I am going to perform a test-driven development kata called the string calculator. I do believe that the kata technique is a very good practice to learn test-driven development, and definitely it's a way to help developers to improve their skills. So before I get started, I want to say a few words about the idea behind a kata. A kata aims to teach us the mantra behind test-driven development. If you were in contact with test-driven development, you probably know that the main principle is the red-green refactor principle, where we write tests that fail on purpose, then we write the minimum code to make those tests pass, and then we improve our code in the refactorization process. So the advantage of this cyclical approach is that at long term we will get a high quality software which is easy to maintain. From the theoretical point of view, the red-green refactor principle is very simple, but many developers get confused when putting it on practice. So I want to go a little bit deeper, not actually a bit deeper, but maybe a little bit more accurate in this explanation of the red-green refactor process. So let's make sure that we understand that first we write a test, then we run the test and see how it fails. So we see that there is a need or there is a requirement because the test is failing. We write the minimum code to satisfy this test, and it is important to highlight minimum because it is not a matter of laziness, but by implementing the minimum we will on our way discover new requirements. So it is important always to implement the minimum. We will run our tests again and make them see that they pass actually. Then we will refactor our code and we will run the tests once more to make sure that they didn't break. Then we will repeat the process. So these are the steps in the red-green refactor process. In this demonstration, I will perform a kata called the string calculator. On the internet you can find many katas. This is just one of the simplest. Here is how a kata looks like. This is the description. And if you want to know more about these katas, you can visit this URL. There you can find more exercises to practice. So now let's go to our IDE and start with the demonstration. Here we are. The first thing I'm going to do is create a project. I'm going to call it the string calculator kata. And the first thing I want to do is to make sure that my project has the libraries that are needed for the unit testing. I'm going to use testng, but you can use JUnit or anyone. I'm just going to use testng. And to start, I'm going to create a test. Let's say test calculate, because calculate is the main function of the calculator. Maybe it would be okay to annotate the whole class as a test, so we don't need to annotate each of the tests. And so to get started with our demonstration, we will need actually to know what are the requirements of the kata. So those requirements, I'm going to just save them here, so I won't be jumping from Windows to Windows. and I will write them here. I just copy paste them from the PowerPoint presentation. Let's see, Kata steps. So here they are. We can put them here, for example, or let's see if Eclipse let us put them here. No, here. It's okay. Let's open the first three. So the first requirement says that an empty string returns 0. So when to our calculator we give an empty string, the result should be 0. So let's start with the test. Public void empty string returns 0. So I will need a calculator, because that is what we are testing. Let's call it calculator. What's new? Calculator. And for this to compile, the calculator needs to exist. So let's just create a calculator. I'm not going to be strict with the naming of the packages now, because this is just a simple demonstration. But you know that tests should be in a package called test. The implementation may be in another package called source or src. Anyway, I'm going to import some of the functions of the TestNG framework statically, because it will be more comfortable for working if they are imported statically. So from TestNG the class assert, I want the assert equals method. Sorry. Yeah, it is control space not working because I didn't say static. Assert equals, yeah. So we want to assert that when we pass an empty string, our calculator gives us 0 as return. So calculator, the method name could be, let's say, calculate an empty string. So when calculating an empty string, we get 0. Let's create that method. We want it to return an integer, and for it to compile, it will integer, let's say, it returns -1. So here is the first test, and so the red-green refactor principle says that we must make the test fail. So we have to make sure that this is a failing test before starting. We will check, and yes, it is a failing test. There it is, failing red. And we will now do the minimum effort to make it pass. The minimum effort to make this test pass is just to return what is expected. Let's run the test again. And we will see that it succeeds. There it is, green. Let's see what is the next requirement. The next step says that if a single number is given to the calculator, it will reply. It will return the same value. So public void single value is replied. Now we need a calculator again. We need this again, but as you see, if we do this, we will be repeating ourselves, and that is not a very beautiful thing to do. So let's extract this as a global variable. Actually, let me do like this. We can initialize it directly there, but let's make it more beautiful and use the test-ng framework to do so. Public void init, and I'm going to use this before test annotation and say that the calculator is equal new calculator. So here we make sure that before each test we have a brand new calculator, clean, and now we can erase this. We can erase this, and we can erase this. So here we were here, and our assertion this time will be the following. So given a single value, we expect this value to be replied. Let's make sure that this is failing. And it is failing. One failure. Go to the code and add some logic. Let's say if the string given is empty, return 0. Otherwise, return integer.parse string. Let's check. It fails. The reason it fails is because I wrote wrong my test. I'm sorry. Let's check again. So it is working. So one thing that we saw our test fail and then we wrote the minimum, we still need to refactor. Well, we didn't refactor in the previous case because there was not much to refactor. We are just returning 0. But this time we want to refactor. Let's refactor this a little bit. Maybe this name is not good. We want to give it something more logical. Let's say input. Let's extract this in a method maybe. Let's say private int transform to int, or let's say string to int, string input, another more thing, maybe we would like to extract also this one in another method, a boolean method. Maybe let's say private boolean is empty, string input, and we are going to call here is empty and pass the input. Let's see that our refactor didn't break the test. So everything seems okay. So I think we are okay to go to the next requirement. And the next requirement says given two numbers, comma delimited, the return should be the sum of those two numbers. Okay, so let's go public void two numbers, comma delimited, return sum. I'm sorry. Assert equals again calculator dot calculate. We are given number 1, we are given number 2. Expected result is 3. Let's run the test. It is failing. We can check. See, 2 passed, 1 failed. We are going now to make implementation for this requirement. So I don't know, let's start here. So if it is empty, we return 0, else let's write an else if is not empty. Or maybe, since we said that we need to write the minimum effort, we just want to say else. So what I want to do in this else, what I want to use in this else is an array of type string that will contain the numbers. And for that, I will split the input using the comma, and I want to return integer dot parse int numbers of 0 plus integers dot parse int numbers of 1. Now Eclipse is advising us that this is unreachable code, so needs to be erased. And now we think we might have enough code to cover this new requirement, but this test still will fail because we broke the previous test. I will show you now. So 2 numbers comma delimited return the sum, but a single value when is replied is not replied correctly. So you see how test driven is our guide for not making or breaking something that was already implemented. The thing is that this method is breaking, even if this is correct. So what happened here is that if else is not good enough, because what happened if just a single value is given, we still need to improve our code to make all the tests pass, not just the one we are working in. So what I'm going to check here is if the length of the input is equal to 1. This will mean that we are in the second test case. In that case, return the input. But we created a method called string to int input. Now, if everything is correct, every test should pass. So see, it is correct. We made every test pass, and the test-driven development approach, red-green refactor, helped us to discover an error in our way when we did actually some refactoring, because new implementation is actually considered as refactoring. So let's see what is the next requirement. Two numbers, new line delimited, returns the sum. Actually, sorry, we cannot go to the next requirement yet. We did not refactor. We just made the test pass. We made every test pass, but we did not refactor. So we need to refactor a little bit more. Let's create a method called getSum that takes, let's say, two numbers, or actually two strings, string num A and string num B. And returns exactly what this code is doing. Num A and num B. And use getSum instead of this. That should be it. Just remove this. And let's see, can we do some more refactoring? If we are satisfied, we can say it's okay. The only thing, of course, to confirm that refactoring is okay, let's see if we didn't break something. So I'll run the test again. All tests are green, so we can continue. Now, yes, we can move to the next requirement. Requirement number 4. Two numbers, new line delimited, returns the sum. So, okay. Public void new line, or let's say two numbers, new line delimited, return sum. So we can say exactly the same as before, but instead of delimiting them with a comma, we're going to delimit them with a new line. Let's see if this fails. Return us. Okay, so this is failing. Good. 3 passed, 1 failed. Let's do some changes to make this pass. For me, the minimum effort to make this pass will be this. So, because you know the split method takes a regex. So that or this should be enough. Let's see. I think yes, it passed. Passed one, sorry, but I only ran one. If you click on one method, it will run one method. If you click on the class, it will run all the methods. So let's run all the methods. Yes, so 4 passed, 0 failed. So it is correct. Implementation was okay. Now let's do some refactorization. I don't know, let's extract this delimiter as a constant. Maybe, you know, we might need it in many occasions, so we don't need to repeat it all the time. Maybe later. So private final delimiter equals to this. Sorry, the type is a string. So I think this refactorization is enough for now. Let's see if we didn't break anything. Okay, we didn't break anything. The next requirement, 3 numbers delimited either way returns the sum. Okay, public void 3 numbers delimited both ways return sum. Assert equals that calculator dot calculate 3 numbers, let's say 1, 2, 3, return the sum. Let's make this test fail. Let's check that it is failing. Okay, it is failing. One test is failing. Let's go do the minimum to fix it. So here are our numbers. We split them, but here the getSum method only takes 2 parameters. Let's make it capable of taking more than 2 parameters. Let's make it capable of taking the whole array and then solve the thing in the method actually. String array numbers. So one of the minimum effort to fix this could be, let's say, something like this. Let's create a loop. Let's call it current. Loop all the numbers and store the sums in a variable of type int called sum, which we will initialize to 0 because it's a local variable, must be initialized. So sum will be plus equal, and now we can use integer parse int, let's say numbers of the current, and just return the sum. I think this is the very minimum. Sorry, I'm going to run the test. It passes, so all tests are passing. Now we go to refactor. So how could we refactor this? Let's say one way could be this. Instead of using a loop, let's use string current. Let's use numbers. Let's use an enhanced for loop. So let's code, and here I'm going to just give current. I think this fix should be enough to make it look a little bit more beautiful. Let's run the test again. It is passing, so we are good to go to the next requirement. Negative numbers throw an exception. So to test if something throws an exception with testng, what we do is say expected exceptions, and we say the type of exception. We can just say exception.class, and what I'm going to say to do is now create the method. Say negative input returns exception. So we don't need to assert anything here. What we need is just call calculate with a negative value sorry. Let's see that first. Let's make sure that this is failing. It is failing, and let's make implementation for this. I think the minimum implementation could be done in this method by checking if any of the indexes contain a negative number. So let's loop these numbers and check if character, or actually let's say if the current, sorry, my integer dot parse int, actually we have the method for parsing, for transforming. We can, let's say, transform into an int. We can use it. And we can also use it in here as we did before, but I'm not going to refactor now because this was part of the previous requirement. So if I make this test green, then I will refactor this, because I just forgot to use this method to make it more, easier to read. Anyway, string to int current less than 0, throw exception with a message, let's say negative input, and I want to use the new keyword, sorry, and add the throws declaration. Yeah, I can add the throws declaration, and this method add the throws declaration again. Now let's go to test, but we see that our tests are actually with a warning because there are unhalted exceptions. We can just add the throw declaration again. I think this should be okay. I don't know, is this a good practice, but I see no reason why should it be bad. Let's see now. So everything is going green. All our tests are passing. So our code is capable of detecting negative numbers. We are going to refactor now. So we did a little ugly code in here. We might want to extract this to another method, and also we said we were going to transform this to string to int current. Okay, and let's extract this to another method. Let's say fire exception. I don't know how good is that name, but anyway. Or let's say find dangerous input. Maybe that this is better. So given a string array of numbers, throw a new exception, and call this here just before the rest of the logic, numbers, and let's see if everything works correctly. Everything is green, so our refactoring was good. And I think we have one more requirement. Yes. So if the numbers greater than 1000 are ignored. So let's write another test. Public void ignores numbers greater than 1,000, or let's say 1,000. We don't need to write words everything. So I'm going to assert equals that given the following parameters, let's say 10, 10, and 1,000, our expectation is 20. I'm sorry. Some brackets here are not placed correctly. Let me double check this. I can't see what is the unhalted exception, sorry. Throws. Yeah. So let's see. The test is failing. This is good. Let's go to the implementation. So the minimum effort, I guess, would be in the loop for getting the sum. So maybe the inputs can be correct. So maybe not in this one, not in this loop, but yes, in this one. Let's say if the current value is greater than 1,000, just continue. Ignore it. Let's check. It failed. Let's see the reason. Okay, it expected 20, but was 1020. It seems like it didn't ignore it. So let's have a look. Actually, I just found the error. If the number is greater than 1000, so 1000 is not greater than 1000. Actually, our code was wrongly, our test, sorry, was wrongly created. This is now greater than 1000. So I think it should be enough and it should skip that iteration. No, it fails again. And now breaks more than one test. Let's see. Let's go to the code. See, test-driven development technique is good because it advises us that we put in risk previous requirements. So probably the reason will be the indexes, why the others are failing. Okay, so we will just focus first in solving this one. and hopefully the others will be solved. So it seems that like I deleted this maybe before while I paused the video to see the report. Anyway, string to int. So yeah, we never did the sum. Maybe I deleted it by mistake. Anyway, let's fire the test again. So now every test is passing. We did it. Let's refactor. I don't think this can be refactored because continue cannot be called if used inside the if used outside, sorry, a loop. So maybe, I don't know, maybe we should just take the whole thing and extract it. Get some, let's say private int calculate values. Now we have smaller methods, maybe more readable. String numbers. Oops. And we can take this from here and bring it here. Say return sum. Calculate the values. So it is more readable now. So the get sum method first checks the dangerous inputs and then calculates the values. Okay, this is a string array, and that's it. Let's see if it is refactored correctly. Yes. So this is the end of the demonstration of this test-driven development kata. At the moment, the time of the recording is 42 minutes. So if we don't count maybe the 10 minutes I expend, or let's say 5 to 10 minutes I spend in the presentation at the beginning, we see that performing this type of exercise is very easy and doesn't take much time, and it can be a really good practice to improve our development skills. So I encourage everybody to give it a try and find another examples. You don't have to do the string calculator, you can do other examples, and just visit the URL mentioned in the presentation. There you will find a lot of katas. I hope you enjoyed this video, and see you next time. Bye bye.